So imagine you're debugging a piece of code to find some issue throughout the day. Or you may be struggling with some code reviews, or you are trying to refactor some monolith application. Or you are maybe trying to understand some complex code. Obviously, we'll encounter this situation in our day-to-day work. In this situation, we always think, what if we have some buddy or senior to discuss and get some guidance? Not always you will have some buddy or senior to help. But what if I tell you there is an AI LLM model which can help you to spot the bugs, which will suggest you optimization, and even it will help you to write clean and production grade code for you. Isn't it sounds interesting? Then you have to watch this video till the end to understand the tool and how you can utilize this tool. So the tool which we are going to use, or the LLM model which we are going to use, is Gemini 2.0. It's a coding buddy that's built to make your life easier. Let's dive in. So Gemini 2.0 isn't just an average AI tool, but it's a developer's dream assistant. Whether you are debugging, whether you are reviewing or optimizing some complex code, Gemini is here to help. Today I'll show you how it can tackle real world challenges in Java beyond just basics. Because most of the models will help you to understand some basic stuff. But let's try to dive in how you can deal with some complex stuff. If you're watching our channel for the first time, please subscribe to our channel and watch this video till the end. If you like this video, please like and subscribe. Let's get started. To access Google Gemini 2.0 models, what you have to do is go to the search bar and search for Google AI Studio. Click on the first link. Once it opens, what you have to do is go to the stream real-time option. So in this you can see talk to Gemini, show Gemini, and share your screen. So in this, what we'll do is we'll talk to Gemini and share our screen and ask her questions. I'll start the recording. After that, I'll share my screen also. So let's do that. Hi Gemini, can you hear me?
Hi there. Is there anything I can help you with?
Yes, I need your help, okay, to fix this code. I have written this Java code called counter as my class name. I'm just incrementing the count value. And whenever I run this code, right, so I'm not getting the consistent result. For example, now I got 92. When I run next time, I'll get something else. So for example, 96. But desired result is 100 because I'm taking
Sure, I can
100.
help with that. It sounds like you have a Java program that uses threads to increment a counter, but you're not getting consistent results. Is that correct?
Yes. Maybe
Okay,
you can
the
check the
problem you're
code.
facing is
Yeah, maybe you can check the code and tell me what needs to be fixed.
okay, looking at your code. The issue is that the increment operation, count plus plus, is not thread safe because it is not atomic. This can lead to race conditions where multiple threads might try to update the counter at the same time and overwrite each other's changes. To fix this, you can make the increment method synchronized, which ensures only one thread can modify the counter at a time. Do you want me to provide the updated code?
Yeah, but before that, I have just one question. So you told about this atomic operation, right? What is that atomic operation means? Can you explain?
Sure, an atomic operation means that the operation happens as a single, indivisible unit. In the context of multi-threading, this means that no other thread can interfere with the operation while it's in progress. So it will appear as if that operation was executed instantaneously. Does that make sense?
Can you explain me a little more detail with an example? Consider that I'm very new to this coding and explain me the issue. Maybe you can take this count as an example and can you explain the issue?
Okay, let's take the counter variable as an example to understand the issue. Imagine two threads, T1 and T2, both trying to increment the counter, which is currently at a value of 5. First T1 reads the value 5, then T2 also reads the value 5. Now, T1 increments its value and writes 6 to the counter. Then T2 does the same and also writes 6 to the counter. As you can see, the counter was incremented twice, but the final value is 6 instead of the expected value of 7. This is because increment is not an atomic operation. Is that clear?
Yeah, sounds good. So can you help me with the fix?
Yes, I can. To fix this, you need to make the increment method synchronized. This will ensure that only one thread can execute the increment method at a time, preventing race conditions. So the updated code will look like this: public synchronized void increment, count plus plus. Would you like me to provide the full updated code for your reference?
Is it fine? I've done the change based on your input.
Yes, that looks good.
So let me try to run
Yes,
this
that's the
code.
correct way to make the... Okay, go ahead. Let me know how it goes.
So I got 100 first time. So let me try to run it one more time. Yeah, I'm getting 100 again. So it looks like it is
Okay, it looks
fixed.
like the code... Great. It seems the issue is resolved with the synchronized method. Is there anything else I can help you with today?
Yeah, I just need one more input. Let's say I'm not using synchronized here. Is there any way I can fix this code? Like, is there any other option to fix this code?
Yes, if you don't want to use the synchronized keyword, you could use an atomic integer. This class provides atomic operations for integers and will ensure that incrementing the counter is thread safe. Would you like me to explain how to implement that?
Yes, please.
Okay, first you'll need to change the private int count equals 0, declaration to private atomic integer count equals new atomic integer, 0. Then you'll replace count plus plus within your increment method with count.increment and get. With this approach, you no longer need the synchronize keyword, and the increment operation becomes thread safe. Do you have any other questions?
I have updated the increment method. How about this one? Get count. What change needs to be done here?
Okay, for the get count method, you'll need to change it to return count. Okay, for get n instead of just return count. This is because count is now an atomic integer, and you must call the .get method to retrieve the actual integer value. This is necessary to keep it thread safe. Does that make sense?
Is it correct?
Yes, that is correct. Is there anything else I can help you with?
No, I think let me first try to run this code. After that, I'll ask some other question. So let's
Sounds
try to
good.
run.
Please let me know if you have any more questions after running the code.
Yeah, I think this looks good. It is providing the correct result. Can you talk about this atomic integer, like how it is solving the problem? How it is different from synchronized?
Sure, atomic integer solves the problem by providing atomic operations on integers, specifically the increment and get method, which performs the increment and returns the new value in a single atomic operation. In contrast, the synchronized keyword locks the method, allowing only one thread to execute the entire method at a time, which can add overhead if the method has many operations. The atomic integer method, however, only locks the variable itself, making it more efficient than synchronization for simple increments, but may not be the best approach if you need more complex operations. Does that clarify things for you?
Yeah, it sounds good. So guys, I hope you understood how you can use Gemini 2.0 to basically debug an issue, get solution for the issue. So with this, you can even understand why you have to do some change and you can understand the background of it. So this will help you to improve your coding skills. Along with that, you can even fix your issues quickly. So I hope you can definitely appreciate this Gemini 2.0. This is like your senior engineer who can help you to improve your coding skills and fix your issues. Let's try to understand one more scenario. Hi Gemini, can you hear me?
Yes, I can hear you. How can I help you?
Yeah, I just need one help. Okay, I've written this class called user service and I have this method called process user. So I need your
Okay,
inputs to refactor this code. Do you think is it better or is there any other way I can improvise this code?
sure, I can help with that. You want to refactor the code, and you're asking if it can be improved further.
Yeah,
Is that correct?
yeah. Can you suggest some changes if if you think it is required?
Yes, I can suggest some changes. I see that you have a user service class with a method called process user, which takes a string user type as an argument, and then it uses a series of if-else statements. I would suggest using a switch statement instead of if-else, because that can improve readability and be more efficient. Do you want to explore this suggestion further?
So why do you think switch is useful over the if else according to you?
Switch statements can often be more readable and maintainable than if-else chains, especially when you have multiple conditions based on the same variable. It also can be more performant than a series of if-else statements. Would you like to see an example?
Just one follow-up. So you talked about the performance part, right? So how do you think switch is more performant than if?
A switch statement can be more performant because it can be optimized by the compiler to use a jump table, which allows for direct access to the code block associated with a specific case. In contrast, an if-else chain may have to evaluate each condition sequentially until it finds a match. Would you like to know more about jump tables?
No, I think let's go for refactoring. Can you suggest me how I have to refactor this?
Okay, let's refactor this to use a switch statement. We can replace the current if-else if structure with a switch statement that evaluates the user type and executes the corresponding code block for each case, admin, customer, or guest. Would you like me to provide the refactored code example now?
Yes, please.
Okay, here is the refactored code using a switch statement. Java public class user service. Public void process user, string user type. Switch, user type. Case admin, system.out. Print ln, processing admin tasks. Break. Case customer, system.out. Print
Sorry,
ln.
you're going a little fast. So actually, I'm just switch user type. What I have to do right? I mean, what I had to write next?
Okay, you want to use a switch statement on the user type, I understand. Do you want me to provide a code snippet?
Yes, please. Briefly explain it. Yeah.
Okay, so after the switch statement, you should add the different cases.
Yep.
Each case will be the user type you are checking for, like admin, customer, or guest. After
Is
each case, you
is
will
it
have the
correct?
code to execute.
Is it correct?
Almost. You'll need to add a colon after the case label, like this, case admin. Then you add the code that you want to execute for that particular case. After the code, you will add a break statement to exit the switch statement. Do you understand this?
Uh, does it look good?
Yes, that looks correct. You've added the colon after the case label, the print statement, and the break statement. Now, you can add the other cases. Do you want to do that now?
I think that's fine. Maybe what I'll do, no, I'll just add one more case. Just wait for a minute. So it's case, and let's take an example, customer, and let me print the system out statement here. Let me add the system out statement here, and I'll remove this if. So this looks fine.
Great. It looks like you've successfully refactored your code using a switch statement and have added two cases for admin and customer. Do you want to add any more cases for other user types?
Now I want to know, like, is this fine, or do you think any more optimization is required here, or any more refactoring is required here?
The current code is fine. You've refactored it to use a switch statement, which makes it more readable and efficient than the original if-else structure. You can add the other cases if needed, but there isn't anything else to refactor here. Is there anything else I can help you with?
No, I think this looks good. Thank you. Guys, I hope you understood how you can use Gemini 2.0 stream functionality to basically refactor the written code. So I hope you can appreciate this functionality. And it is like almost interacting with your senior and getting some feedback and optimizing your code or refactoring your code. Isn't it interesting? So I hope you understood how you can use this Gemini tool to basically refactor your code. Let's try to explore some other cases as well. Let's say you have written some code and you need some review on that. So because not every time you can go to your senior or others to ask for review, but let's say you want to get some review from an AI tool, which is almost like your senior. So let's try to see how we can achieve that. Yeah, consider yourself as a senior engineer, okay? Maybe an architect or senior engineer in the company, and you have to review this code. So, starting from class name, variable name, method names, error handling, resource management, and efficiency of the logic, everything you have to review. So, can you review it and give some feedback on this code?
Sure, I can review the code and give you some feedback. Let's start with the class name. USR press ear is not very descriptive. It might be better to use a more meaningful name that indicates its function. For example, user processor.
Okay. And how about method names and other things? You can go further. I'll update the code afterwards.
Okay, let's look at the method name. The method process user is okay, but it can also be more descriptive and specific to its action. For instance, if it was processing user information from a file, perhaps a better name could be process user from file.
Okay. And is it a correct notation? Like I'm basically using Java. So Java method convention, is there any method convention, method name convention I have to follow?
Sure, method names in Java should typically start with a lowercase letter and use camel case for multiple words. So process user should be process user, or even better, process user from file, as previously mentioned. Variable names should also start with lowercase. Additionally, the variable br should be closed in a finally block to guarantee proper resource management.
Okay. How about these names? Is it fine? Like BRL, is it a valid name or do you suggest any better names?
Okay, while br and l are valid variable names, they are not very descriptive. Br could be changed to buffered reader or reader, which would be easier to understand. Similarly, RL could be changed to line or current line to indicate what it represents.
Okay, sounds good. Yeah, maybe you can proceed with the code. You're telling about something finally, like why I have to add finally actually.
Okay, the reason for using a finally block is to ensure that resources, like the buffered reader BR, are always closed, even if an exception occurs within the try block. This is very important to prevent resource leaks and ensures the program behaves correctly.
Okay. So is there any better way in Java newer versions? Like instead of finally, can I do something better which will auto close the resource?
Yes, in newer versions of Java, you can use the try with resources statement. This ensures that resources are automatically closed at the end of the try block, and it removes the need for a finally block to manage the closing of those resources.
Got it. So yeah, you can proceed with the code review. So is there any other change I have to do in this code?
Okay, looking at the code, the split method uses a regular expression with a space. It is better to avoid regular expressions if you are just splitting by a single character. In that case, the simple split method without regex will be better. Also, it would be good to include some checks if parsing from a file may result in null or empty lines.
Got it. Yeah, you can proceed to the next lines.
All right, the next thing I see is you are using a for loop to print the map entries using the entry set method. It would be better to use the for each method on the map to achieve the same goal with a lambda expression. This would make the code more concise and modern.
Got it. And how about this exception? Is it fine?
The catch block currently has a generic exception handling with a message, "Oops, something happened." It would be best to handle specific exceptions and provide more meaningful error messages, maybe even log errors. This way you can handle I/O exceptions, parsing exceptions, and any other exception that may occur independently and accordingly.
Got it. So in the previous section, we learned how we can use Gemini to basically act as a code reviewer for your code. So you understood how effective code reviews it can provide. So in the next section, what we'll do is we'll take up some code with to-dos and we'll ask Gemini to basically code the solution. So let's see how it will suggest you what kind of changes you have to do. Let's dive in. Yeah, so I hope
Okay,
you can
what about
see
it?
I hope you can see my screen clearly.
Yes, I can see your screen clearly. Do you have any specific questions about the code you are showing?
Yeah, actually, I'm writing this LRU cache, and you can see I have this constructor put, get, and display cache and main method. But you
Okay,
can
it
see a
looks
lot
like you're
of
working on an LRU cache implementation in Java. You have a constructor, put, and get methods. What part of the implementation are you focusing on right now?
yeah. I need your help to complete all the to-dos. You can see to-dos in multiple places, starting from constructor, put, get, display cache, as well as in the main. So I want you to know what code I have to write.
Okay, it sounds like you'd like help completing the implementation of your LRU cache. You
Yes.
have the basic structure set. Yes, I understand that you need help implementing the to-dos of your LRU cache. Let's start with the remove eldest entry method. Do you want me to provide the implementation, or would you like to try and code it yourself with my guidance?
Yeah. Please provide the code. Actually, what I have to add it here.
Okay, for the remove eldest entry method, you can simply return cache size greater than capacity. This will ensure that when the cache size exceeds its capacity, the least recently used entry is removed.
Okay. Can you tell the code what I have to write here?
The user asked for help implementing user and the to-dos of their LRU cache, starting with the remove eldest entry method, and I provided them with the code return cache jot size greater than capacity. Do you want me to continue with the next to-do?
So you mean to say, do I need to write like this if it is greater than capacity? Is it correct?
Yes, you're correct. The code should be return cache dot size greater than capacity. I apologize for not including that in my last response.
No issues. Can you talk about this put? What I have to write here?
Okay, let's move on to the put method. In this method, you'll need to add the key value pair to the cache. Would you like to try implementing it yourself, or should I provide the code?
Yeah, please provide the code actually.
Okay, for the put method, you can use cache.put key value. This will add the key value pair to the cache, and due to the linked hash maps behavior, it will also handle the LRU aspect of the cache.
I hope it's correct.
Yes, that's correct. The cache.put key value is the correct way to add a new entry to the cache in your implementation. Now, are you ready to work on the get method?
Yes.
All right, for the get method, you need to retrieve the value associated with the given key. If the key is not present, you should return null. Do you want to try it, or should I provide the code for this one as well?
Maybe I'll try to write the code. Okay. So it's like dot
Okay,
get.
sounds good. I'll wait for you to write the code for the get method, and I'm here to help if you get stuck or need any clarification.
Sure. So let me
Okay,
try to
you've
write.
started with Okay, it looks like you're using cache.contains key in the if statement. That's a good start. What should you return if that condition is true?
Yeah, I'm basically returning whatever the cache contains. I'm doing cache.get of key. If it does not contain, I'm returning null. Is it fine?
Yes, that's perfect. If the cache contains the key, you return the value using cache.getKey. And if it doesn't contain the key, you return null, which is what is currently on line 28. Is there anything else you need help with, or any other part you want to discuss about the code?
Yeah, I want to complete this display code as well. So what I have to write here to display the cache?
Okay, let's complete the display cache method. This method should print the current state of the cache.
Yep.
How would you like to display the cache content? And would you like to write it yourself or get my help?
Can you please help me with that?
Okay, to print the cache, you can iterate through the entries of the cache map. Here's how you can do it. Java for entry less than k, v greater than entry, cache.entry set. System.out.println key plus entry.get key
Can you
plus
help me with some
value.
Java stream example?
Yes, I can help with that. To use Java streams to display the cache, you could do the following. Cache.entrySet.stream.forEach. Entry to system.out.println. key plus entry dot
If you
get
don't
get
mind, can you go a little
key.
slow? I have written this much. What I have to write next?
Okay, you have cache.entryset.stream.forEach. Inside the forEach A, you need to provide a lambda expression that will print each entry. You can use entry to system.out.println key plus entry.get key plus value plus entry. Get value to print the key value pairs of the cache.
Sorry, I still couldn't follow. So I'm in a for each. Okay. So what I have to do now? Can you
Okay, no
go
problem.
one by one?
Okay, let's go through it step by step. First, you have cache.entrySet. This gives you a set of all the entries, key value pairs, in your cache.
Yep.
Next, .stream converts this set into a stream. Then, .reach is a terminal operation that performs an action for each element in the stream. Now, you need to provide that action. The action is specified using a lambda expression inside the for each.
So how to do that? Can you explain?
Yes, the lambda expression will take each entry in the cache's input and use it to print the key value pair. So inside the parenthesis of for each, you write entry to system.out.println key plus entry.get key plus value plus entry.get value. This code will take each entry from the stream and print its key and value to the console.
Does it look correct?
Okay, you've got it. Now, the display cache method should print all the key value pairs in your cache. Is there anything else you'd like to work on or any other questions about your LRU cache implementation?
Yeah, I just want to complete this main method. Can you help me with that?
Yes, let's complete the main method. It seems like you have some example code already in place as comments.
Yeah.
Do you want to uncomment those lines and run them? Or is there anything more you'd like to add in there?
Is this look fine? Is it look correct?
Yes, the code looks fine and correct. You're creating an LRU cache with a capacity of 3, putting a value, getting a value, and displaying the cache content. If you run this code, it should behave as expected. Is there anything else you'd like to do with this code?
Yeah, actually, I'm running this code now. Guys, I hope you saw like how you can use Gemini 2.0's help to basically complete the code and do the testing. So because many of the times what will happen is we'll stuck while coding. We may need somebody's help to basically complete the code. And we will require even explanation also why we are writing something. So I would recommend Gemini 2.0 as the best buddy for your all coding activities. So it will provide good guidance. It will help you to basically understand why you have to write something and how you have to write it. So I hope you understood it. So the previous section we understood how we can code LRU cache using Gemini 2.0. So this can be a day-to-day activity. Many of the times when we start something, we will stuck to proceed coding. So you can use Gemini to basically fill the gap. Next up, what we'll do is we'll take up some complex code. So that can be written by your peers or it can be a legacy code. So it's almost same as that. And we'll ask Gemini to explain the code to us. Let's see how it goes. Yeah, actually, I have this code, okay, this complex process. It's written by someone else. I am not able to understand
Okay,
what this class is doing. Can you help me to understand that?
sure, I can help you understand the code. It appears to be a Java class called complex processor. What parts are you finding particularly confusing?
Yeah, it's like the complete code I'm not able to understand. So what I'll do is I'll just show
Okay,
you the
let's break
complete.
down the whole code then.
Yeah,
It
I'll
appears to be using Java's completable feature to process a list of strings. It starts by creating a list of string called data that contains the strings task 1 to task 5. Then, it creates a thread pool with 4 threads to do processing on it. Does that make sense?
yes, please continue for remaining part also.
Okay, so after creating the thread pool, the code uses completable feature to perform asynchronous operations. First, it takes the initial list of strings and maps each string to a new string that has processed prepended to it, and it collects the processed strings into a new list. After that, it filters the processed strings to keep only those containing the character 3. Finally, it maps this filtered list to another list, where each item is now a completable future that simulates expensive work, and it sleeps the thread for half a second before returning. Is this explanation helpful?
No, I just want a little more depth actually. Consider me as like a fresher. I'm just trying to understand the programming. And can you explain me what is happening in this code?
Okay, let's go through it step by step, keeping in mind you're a beginner. So the code starts with a list of strings. Then it uses something called a stream to perform operations on those strings. The first operation is to map each string to a new string with processed in front of it. Then it collects these new strings into a list.
So what
Next,
happens
the
here?
code filters this list.
Sorry to interrupt. Like what happens here? Like at this point, what will be the output?
Okay, so after the map operation, the strings task 1, task 2 inches, task 3 inches, task 4, and task 5 inches become process task 1, process task 2 inches, process task 3 inches, process task 4, and process task 5. Then the collect method turns this stream back into a list.
Okay, please proceed. What happens next?
Okay, so after that first step, the code uses then apply async to process that new list of strings asynchronously using the thread pool. It then filters the list to only contain strings that include the character 3. So after this step, the list will only contain process task 3. Is that clear so far?
Yeah, actually, what happens here? Like, what is the, I mean, you're saying it contains three. So what is the
At
output
that
at this
point,
point? Yeah.
right, after filtering, the list will only contain process task 3. So at that point, the output of the list will be just that single string.
Okay. And what happens next, actually?
Okay, after filtering, the code uses then compose async to chain another asynchronous operation using the thread pool. It takes the filtered list, and for each item it creates a completable future that simulates some expensive computation, which in this
Hmm.
case just sleeps for half a second. It then adds final to the string. So after that step, the output will be a list that will have only the string process task 3 final. Is that understandable?
Yeah. Can you explain the remaining part of the code?
Sure. The remaining part of the code waits for all the completable future objects to complete using the completablefuture.alloff method. It then maps the list of futures to a list of strings by joining the results of those futures. Finally, it prints the final result and shuts down the executor service. Does this make sense?
Okay. So, and there is this result for each, right? What it prints?
The result.forEach system.out print LIAN. Part of the code will print each item in the final list to the console. In this case, it would print the single string process task 3 final.
Okay. Just assume that you are going through this. I mean, you are a developer, and this code is given to you, and you have to basically see if this is
Okay, so
fine.
as a developer,
Yeah, is this fine, or do you think can we achieve the same thing with the lesser complexity?
looking at this code, I'd say it's functional, but there might be simpler ways to achieve the same result, particularly if you don't need the asynchronous processing for each step. It seems overly complex for just filtering a list of strings. There's a few areas where we could simplify, for example, the filtering and the expensive computation.
Okay. So can you explain me how to do that?
Okay, if we want to make the code simpler, we could remove the need for the thread pool and simplify all of that asynchronous processing. For instance, we can use a single stream to do mapping, filtering, and adding the suffix. It would look something like this: data.stream.map, item to processed plus item, .filter, item to item contains 3, .map, item to item plus final, collect, collectors.toList. Would give the same final output with significantly less complexity.
Okay. Sounds good. Thank you. So in the previous section, we learned how to use Gemini to understand some complex piece of code. So this code can be written by you or your peers, or it can be legacy code. So this is like a day-to-day work only. Many of the times we have to understand someone else's code to basically extend it or modify it or refactor it. So you understood how Gemini is helpful in that. And next up, what we'll learn is we'll take up some code and we'll ask Gemini to basically come up with some JUnit cases. So normally, like, coding is one of the important thing. Along with that, testing the code is also as important as coding. So we'll understand how you can use Gemini to basically learn to basically code the JUnits. Let's dive in. Yeah, actually, I have this class called calculate. Okay. So I have a couple of functions like
Okay,
add,
you have a class
divide.
called calculator. What do you want to know or do with it?
Yeah, I have this method called add and divide. So I want to know like what are the JUnit cases I can write for this.
Okay, you want to know how the add and divide methods work in the calculator class, and you also want to know about the JUnit test. Is that correct?
No, I just want to add some JUnit test cases. So can you help me with that?
Okay, you want to add some JUnit test cases for the calculator class.
Yeah.
I can help with that. Do you want to start with the add or the divide method, or maybe both?
Yeah, we'll start with add. After that, we'll move on to divide.
Okay, let's start with the add method. What kind of test cases do you have in mind for it? For example, do you want to test with positive numbers, negative numbers, or zero?
Just consider I'm a beginner, okay? I don't know like what are the test cases I have to cover. I have to just written this code and I need
Okay,
your
no
help to come
problem.
up with different test cases and the code for the same.
Okay, as a beginner, let's start with some basic test cases for the add method. We
Mhm.
should test adding two positive numbers, adding a positive and a negative number, adding two negative numbers, and adding zero to a number. How does that sound?
Yeah, I think it sounds good. So let's say if I have to write it in JUnit, right? How to proceed, like what I have to do actually?
All right, it sounds like you're ready to start writing some JUnit tests,
Yep.
and you want to know how to proceed. Let's start by writing the basic structure of a JUnit test class and a test method. Would you like help with that now?
Yeah, I need your help. Basically, I don't have any dependencies also added. So like from where I have to get the dependencies for JUnit
Okay,
and how
sounds
to.
like you need help setting up the dependencies for JUnit.
Yep.
You'll need to add the JUnit library to your project. Are you using Maven or Gradle for your project?
I'm using Maven actually.
Okay, you're using Maven. To add JUnit as a dependency, you'll need to add a few lines to your pom.xml file. Would you like me to help you with what to add?
Yes, I have this pom.xml. Okay, can you help me what I have to add?
Yes, I can help you with that. Within the pom.xml file, you'll need to add a dependencies section, and inside of that, add the JUnit dependency. Would you like me to show you the XML tags for that?
Yes, can you explain me what I have to add it here or where I have to add?
Oh, sorry about that. You haven't added the dependency yet. You've shown me the current contents of your pom.xml file, which includes the basic project information and some properties.
Yep.
To add the JUnit dependency, to add the JUnit dependency, you should add a less than dependencies greater than tag right after line 10, which contains less than properties greater than. Then inside the less than dependencies greater than tag, you'll add the JUnit dependency within its own tags. Would you like me to provide you with the specific XML to copy and paste?
Yeah, let's say I have to search it in the internet. Okay, so what should be the keyword and how to search it for the dependencies? Can you help me with that?
Yeah, I can help with that. The keywords you would use to search in the internet for the JUnit dependency in Maven are JUnit Maven dependency. That should help you find the XML code needed for the dependency.
I have opened the link and then I have done the searching. I'm seeing this link. Is it correct?
Okay, you've done some searching and found a dependency. It looks like you've added the less than dependency greater than tags, but you'll also need to include the group IED, artifact ID, and version for the JUnit dependency inside. Would you like help with that?
Now I'm showing you the dependency page. Is it the correct one? Shall I take this?
Yes, the structure is correct. Now you'll need to fill in the specific values for group ID, artifact ID, and version within those tags. Would you like me to provide that information?
I have done it. Is it correct?
Yes, that looks correct. You've added the JUnit dependency with the correct group ID, artifact ID, and version. You've
Cool.
also added a scope tag. Is there anything else I can help you with?
Now can you help me like how to add test case and where I have to create my test classes?
Okay, now that you've added the JUnit dependency, let's create a test class. Typically, you would create a new folder under src called testing, and then a folder called Java inside that. You'll want to create a new Java file inside that test/Java folder. Would you like help creating that file now?
Yeah, can you help me like what should be the class name?
Okay, for your test class, a good naming convention would be to use the name of the class you're testing, followed by test. So for the calculator class, you could name your test class calculator test. How does that sound?
Sounds good.
Created a class called calculator test. Now, what specifically would you like to do with that class?
Yeah, actually I want to add test cases for add and divide. Can you
Okay,
help
you
me
want
with?
to add.
Yeah.
Sure, you'd like to add test cases for the add and divide methods of the calculator class. I can definitely help with that. Do you want to start with the add method, or would you prefer to start with the divide method?
Let's start with add method actually. Can you tell me what code I have to write here?
Okay, let's start with the add method test. You'll need to write a test method within the calculator test class. Here's the basic structure you can use. First, add the annotation at test above a new method. Then, inside that
Is it
method,
correct? Is it correct?
yes, at test is correct. That annotation marks the method below it as a test method. Now, what do you want to name the method below the annotation?
Can you help me? What is the standard? Like consider like I'm a beginner. So can you help me? What is the standard way to define a method
You're
for
asked
test
about a
cases?
standard naming convention for test methods.
Yep.
A common practice is to name them starting with test, followed by the method name being tested. For example, since you're testing the add method, you could name your test method test add. Would you like to use that naming convention?
So you're saying like can you completely explain the signature? What I have to write here?
Okay, let's complete the method signature. After the add test annotation, you need to add the visibility modifier, which is usually public say,
Mm-hmm.
then the return type, which is usually void add, and then the name of the method, which we agreed would be test add. So the full method signature would be public void test add. Would you
Is
like
it
to add this now?
is it correct?
Yes, that's correct. You've added the at test annotation and the method signature public void test add. Now inside the curly braces of the method, you'll write the actual test logic for the add method. Are you ready to move on to writing the test logic for the add method?
Yes. Please tell me what I have to write here.
Okay, to test the add method, you'll first need to create an instance of the calculator class. Then you can call the add method with some sample input values. Finally, you'll want to use an assertion to verify that the result of the add method is what you expect. Are you familiar with JUnit assertions?
Not really. Actually, I just created this instance. Can you tell me what I have to write next?
Okay, you've created an instance of the calculator class. Now you need to call the add method on that instance and store the result. You'll also need to define the input values you will pass to the add method. For example, you could call the add method with the inputs 3 and 5. How would you like to do that?
Yep, I have added that. Like, so you're saying I have to capture the result in some variable here?
Yeah, that's correct. Yes, you need to capture the result of the add method call in a variable. You can declare an integer variable and assign the return value of calculator.add35 to that variable. Would you like me to show you how to do that?
No, I have done it. Like, can you explain me what I have to do next?
Okay, you've called the add method and stored the result in the result variable. Now you need to use a JUnit assertion to check if that result is the expected value, which in this case would be 8. Would you like me to show you how to add that assertion?
Yes, please tell me.
Okay, add the assertion and you will use the assert equals method from JUnit. You'll write assert equals 8 result ping, where 8 is the expected
Sorry,
value.
I'm not
And
getting the option. Like, I'm just getting assert, but you're telling assert equal. Can you tell me how to get it?
you're right. The assert keyword by itself doesn't do anything. You need to call a specific assertion method, like assert equals. So the
But
correct
I'm not
line should
getting the
be assert.
suggestion. I'm not getting any suggestions for that. Can you help me with that?
Okay, it looks like your IDE is not giving you suggestions. A method you need is called assert equals.
Can
It
you,
is a static method.
yeah, since it is static, right? Can you help me like how to import that? Or can you tell me what class I have to use?
You're asking which class to use for the assert equals method?
Yep.
It's part of the assert class from the org.junit.assert package.
Is it
Since you've
correct?
already imported, yes, that is correct. You've imported both org.junit.assert and org.junit.test. Now you can use the assert equals method from the assert class. Would you like to
Yes.
do that now?
Yes, I've done that. Like now what I have to pass it here?
Okay, you've added assert equals. Now inside the parentheses, you need to pass two arguments, the expected value and the actual value. The expected value in this case is 8, and the
Hmm.
actual value is stored in the result variable. So the
Okay.
line of code will be assert.assert equals 8 result. Does that make sense?
Yes, I have added that. So is it good to run?
Yes, it looks like your test method for the add function is complete and ready to run. You've created an instance of the calculator, called the add method, stored the result, and asserted that the result is what you expected.
Finally, we reached the end of this video. So in this video, we learned starting from debugging race condition to refactoring a legacy code, understanding some complex piece of code, how to write JUnit, and how you can use Gemini as a code reviewer. So all these things we learned in this video. So Gemini 2.0 takes your coding experience to the next level definitely. It's like having an expert developer by your side 24/7. That too, it's free. So don't let your code slow you down. Try Gemini 2.0 today. If you found this useful, if you found this helpful, like and subscribe. And if you have any questions, you can ask in the comment section. And one more thing is this Gemini 2.0, it's in the experimental phase. So it may give some wrong answer. So it's not like always it will give you the perfect things. So it's in the evolution phase. Definitely this will improve over a period of time. But for the time being also, it will be definitely helpful to your day-to-day work. So let's catch up in the next video. Thank you. Happy coding.